Swayam Prabha. Digital India. Educated India.
Okay, now I want you to draw this network and I am going to give you some values. I want you to draw this network, I will give you some values to be able to practice this crashing exercise. So draw the network and then I will get back to it. Okay, so I am going to now give you this as an exercise. So you have to, so here is the normal duration, the crash duration, normal cost, crash cost. You can assume an indirect cost of 125 per day. Okay, and let's go through, I mean first do the exercise for a few minutes and then we will solve it on the board. Okay, you got the values down? How will you find, you can find the optimum point by comparing slopes, but why don't you crash it to the maximum? So we can draw the cost time curve. Okay, shall we start so that we can then solve it? So I've done only the forward pass here, but that gives us an idea. Simple network, we can see where things go, and critical path is going through B and F. So my first step, I want to start crashing. What would be my first option? What are my options? B at 150 or F at 50. Obviously I will choose F at 50. Okay, and how much can F can go all the way from 5 to 2. Okay, let's just decrease it. We'll take it stepwise again. 5 to 4, 4 to 8, goes to 8. Okay, so my second step, again I'm here. So now what has happened is F and D have both become critical. Okay, because this is going through 8. So now my critical path is going to D also. And what are my options? Yeah, I have B, still B at 150 or F and D at 200. Okay, and again B now affects both F and D, so crash B is more economic. So I go down to, how much can B can go down to 3. This goes to 3. Okay, I'll use a different color for this step. 3, and now this starts at 3. Okay, goes to 7. Again 3, 7, and my project duration is at 7. Okay, my third step, and now my B has fully crashed. So I have to crash. Yes. Now here is 6, here it's come to 7. So now with coming to 7, you find that A, C, E has also become critical. So I can't crash D and F alone anymore. I have to crash combinations. What are my combinations? So I certainly have to crash D and F, right? So there's D, F, A, one combination. Okay, D, F, A, or D, F, C, or D, F, E. Okay, what are the values? DFA 225,
EFC at 200 plus 350,
350,
EFE at 400.
E is expensive to crash. Okay, so D is 550, 600. Okay, my choice would be DFA, and I'm going to crash it. So now what, A can go only up to so I'm going to crash, A goes to 3. Okay, so this goes 0, and then my D goes to all are going to 3. So this path becomes 3, 3 to 5, 5 to 6. Okay, so this becomes, this nothing changes, only the duration, 3 to 6. Okay, here again 3 to 6, and this becomes 6, 6. So now my A is also fully crashed out, B is fully crashed out. My combinations left are there, is there anything more possible? Okay, so now what about D? What is the duration of D? Can go all the way up to 1. What about F? F can go up to 2. C can go down to 1. Okay, F and C are limiting, I cannot, so I can take only one more step, and that will be that. So from on my fourth step I have option DFC at 350 or DFE at 600. Okay, and I will choose DFC at 350 which means C goes to 1, 4, 5, this goes to 2, and this goes to 2, okay. So this would be the sequence in which we crash, and let's just go through the slides again. So we can see the options for crashing. Okay, we first crashed F, and then we found there is BF and BD work, I mean the path went through D and F. So in the second step we have to crash B, we crashed it to the maximum and we could not after that take B any further. Okay, in the next step we went on to with these options and we took the ADF option and could not be crashed. Okay, now we have all of it, and in the last step we took the CDF and we finished it in 5 days and we could not crash anything. Okay, now if we add the, what is the duration you got as for minimum cost? Did you come to that computation?
5 days.
No, that is the minimum duration.
So we have to calculate the
You have to calculate the indirect cost. So here we go, we have put the indirect cost per day, the total indirect cost, and we started with 2475 as a total, comes down to 2400. Okay, then starts increasing. Okay, and we can see the first cost we incurred was 50, after that it went to 150 second day. Remember, increase in cost in the second step, by bringing it down for 2 days it went to up by 150, whereas the slope of the first one was only 50. What is the indirect cost? 100. So after that any reduction cost us more in direct cost than savings in indirect cost. That is why the first step is where the savings come. Okay, and so this is the optimum total cost and the optimum duration of 8 wise, optimum in this case being minimum, and this is the relationship graph. Okay, so if you plot the graph you will find that this is how the trend goes. You see in the first step, I mean after we reduce it to the first, here this is where we get the optimum. Every other time we reduce, the direct cost slope is higher than the indirect cost slope. Okay, so to summarize what we have done in this lecture, we looked at relationship between activity, direct cost and duration. We saw the assumptions that need to be made. So if you recall, this was the graph which we showed how we make this linearity assumption, and that really limits a lot of things, but it is only for the ease of calculation. We went through the procedure for finding minimum direct cost for crash project durations, then we included the overhead cost and we found the duration at which total cost is a minimum, and this is a very interesting relationship, and we have to see how this can be applied on projects so that we can actually find minimum overall cost. Okay, we will continue with this topic for one more lecture, especially with different calculations and also various other variables like say liquidated damages, which will come and change as you change the whole equation as you start reducing duration. Okay, and this is a problem which I am going to assign as homework. We will start out the next class with a solution to this problem. Okay, thank you.